All right. Hello, everyone. Professor Caudill. And today, oops. All right. Today we are on Freefall 66. So we want to find displacement. So we want to find D at T is 5.5, 1, 1.5, 2. For a ball thrown straight up. So accelerations would be negative. Gravity. Okay. So we want to find displacement. Okay, so we can use equation 2, but we don't know average velocity. So we didn't need to know a final velocity. So we could also try equation 4. We'd be solving for x. We know v naught, t, so probably equation 4. So we're going to solve for x, which is y in this case. We're going to do negative 9.8 time. Let's start with 0.5 and 15, 0. Okay, so 6.25. So we're going to get 6.3. Okay. 4x, negative 9.4, x, 9.8. Now we're going to do 1 second. 15, 0. So we're going to get 10.1. Time is 1.15, 15, 0, 11.5. That's weird. It was just working. We're doing function 4, x acceleration. So function 5 might be broken. We have to look at that. Not necessarily right now. So 10.4. I will say I will add function 5 might be broken. Let's right. I'm gonna take a moment just to see if we can fix this. Literal. Okay. So what does this have that this doesn't have? Got. Okay. So it definitely doesn't understand what I meant here. And this should be after this. Actually, this should be after acceleration. Okay, so what is different? So we have if, v naught is numeric. Okay, so maybe I could add something like this. Not sure if this will work. X. No. Okay. Func is selected functions. Func. 5. Okay, so we have final velocity 10, 10, x, 5, 5. Five, 10, 10, x, 10, 10. All right, so there we go. I think I fixed it. So I'll upload this change to the GitHub. So what did we even change? Not entirely sure what we even changed. Maybe this. I don't know. Whatever. So let's move on. Okay. So we found the displacements. 66. We can move to 67 now. Calculate displacement. We'll find D at D is 0.5, 1, 1.5, 2, 2.5. So rock thrown straight down. So let's say this X or Y, it's thrown straight down. So V naught is 14. Acceleration is 9.8. If you graph a free fall problem as an object falling down the origin, would gravity be negative? Okay, so it should be a negative value. Hoping. $70 meters above water. So X so we're going to be falling 70. So I can say X naught is 0. No, I'm sorry, I should say Y naught is 0. Y is negative 70. So I think all these are coherently placed. So if we're making acceleration negative, hoping probably means this is wrong on the top. Let me just backtrack to 66 real quick. We're doing, okay, so why is this displaying here? Okay, so let's try this for, we had displacement was what we're solving for. Let's try negative 9.8, 0.5, initial velocity 15, position 0. Okay, so it's not giving us a result. Let's try again. Y says There we go. Sorry about that. So we're doing 4. Displacement is x negative 9.8. Again, I'm on 66. I'm just time is 0.5. Velocity 15, 0. 6.25. So getting the same answer. So hopefully it doesn't matter too much. Okay, so let's try this. We're doing equation, what equation we're using? 4 again. Solving for t, no, 4. 4. What are we looking for? Displacement with times. We know our initial velocity. We know v naught. V naught, okay. I think they're asking y naught is 70. It's asking how far it travels down in those seconds. Okay, so we're gonna get at like negative. Okay, so really this should be like this. Yes. This is our bridge. Dropping it down. Okay. I think that makes more sense to me. So we're gonna do function 4. Displacement is x. Negative 9.8 t 0.5 70. No. Okay. Want to retry? Function 4. Solving for x. Negative 9.8. 0.5. Initial velocity 14. Initial position 70. Okay, so we have 70. 5.8 the first try. Our units all the same. Meters seconds. Okay, so this 75.8 meters is how far it dropped. Now, does this make sense? So this is the water, so it's saying it's going 5 feet below the water. So it's saying 5.8 meters below. Went 5.8 meters below water. And we're assuming there's no resistance. Okay, so I think that's what this is saying if you're putting it in English. So we're going to do it for the next numbers. Displacement. Excuse me. Times 1. 4x negative 9.8 1 14 70. Okay, 79.1. Okay, why did it jump up here again? I don't know. It might just be like computation thing. I don't really know how to fix that. It's like because it's this sometimes drops below the chat box, the whatever the box is where you type in. Sometimes it drops below that, and it's like inconsistent. So I think it's like a computation thing. All right. So what are we doing? I think we're just doing the next problem. So okay, so for displacement, it's x negative 9.8 times 1.5, 14, 70, 70, let's say 80. So it hasn't jumped yet. Negative t is 1.15, 14, 70. Okay, and I must have already done that one. My bad. So yeah. So this is, I don't know, like the chat, the, this method is nice for like one-offs, but when you're like doing a bunch of numbers, you have to type a new one each time. It gets kind of tedious. So I still think we save time because doing like something where we're doing a bunch of numbers, that's more rare than just doing the one-off ones. So I think this is better, even though in this specific case it seems tedious. But it's really not in the long run, I would say. Okay, so when you press the first number, it switches, it moves up. I don't know if you noticed that. So that's kind of weird. 2.5 and 74.4. Okay, so that's 67. Move on. 68. 68. Fastball referee tosses the ball straight up. So the ball is here. What velocity must a fastball leave the ground? So we want to find V naught. We want to find V naught. So V is 1.25. Okay, we know A is negative 9.8. So I guess we could say this is y. It starts at the ground, goes up. So we want to find v. Okay, I guess v naught is 0. Starts, but we want. Well, yeah, we need him to leave the ground at a certain velocity. When he gets here, his velocity is 0 because if you remember, if you throw an object up at the peak, the instantaneous velocity is 0. So when he attempts to get the ball, he's floating in air, like he's not. So I think his final velocity is 0. So I think that's the key kind of like intuition you need to bring into this problem. So we're going to find what equation we want to use. So we know v, we need to find v naught. Okay, we know a, we don't know t. So I'm looking at equation 5. So final velocity is 0, negative 9.8. Displacement is 1.5, 1.25 from 0. Initial velocity is v naught. That's what we want to find. So I'm getting 5 meters a second. Okay, so I don't really think there's too much to say about that, so I think we can move on. Sorry. Okay, 69. Helicopter. Helicopter is hovering over a person. Okay. One of the rescuers throws a life preserver. V naught is 1.4. So T naught is 0. Okay, so don't know why displacement, but we do know why not will have to be, and we do know y will be 0. Why not is unknown. We don't know how high the plane is. So this is our why not. But y will be 0. You know, a is negative 9.8. Or I could say g. Okay. Is that all we know? I think that's all we know. Okay, so we want to find, so given all this is our picture. We don't know. We want to find why not. Okay, and all right. So we're just finding why not. So So I'm probably equation 4. Okay, so we're going to use equation 4. 0, negative 9.8, 1.8, 1.4, initial position. That is x naught. So I'm guessing the plane is 13.4 meters high. All right, 70. Dolphin in an aquatic show straight out of the water. So it's jumping out of the water at V. So V naught is 15. Okay, G 9.8. Y naught is 0. Okay, we know Y will be 0. No, I'm sorry. V will be 0 because when it reaches the top, it will be not moving at the top. So our final velocity is going to be 0 at the peak. So with this, you want to calculate Y. Okay, so you'll probably use equation 5. V is 0. A displacement. That's what we're trying to find. Initial position is 0. Initial velocity 15. Okay, so 11.5 meters high. Okay, so how long a time is dolphin in the air? Now I want to know T. Okay, how long is time in the air? So try equation 3. V 0, negative 9.8, T, V naught is 0. Initial velocity is 15. So 1.5 seconds seems reasonable. So I would say this is pretty reasonable. I don't have any issues with this. Okay. Diver bounces straight up from a diving board. Diving board, we have water, straight up. Okay, so he's gonna hit the diving board. That's not very smart. Okay. Oh, so he's avoiding it. So he's straight up, but it's gonna avoid it somehow. I guess maybe the diving board is gonna move back, or he goes at an angle. Straight up, straight quote straight up. All right. So she starts with the velocity. V naught is 4. takeoff point is so why not is 1.8. Okay. So we're going to use solving for y, probably doing equation 5. So solving for, final velocity is 0, -9.8. So we don't know x, but we know y, 1.8. So 2.6 meters. Okay, time in the air. Zero, 9.8, that's 4. So I'm getting 0.4 seconds. I'm having doubts because if v is like v could be this is a peak, so it's saying calculating how long she's in this air, but we also need to find out how long this is, like the time. So what we really need is so we found the displacement, so we know this is 2.6, right? So maybe I'm thinking it's uh not. So is this 2.6? Alright, so why not is here. So here's why not. She jumped up. So we try to find y. So we found y with the displacement. So, final velocity. Okay, so we found this is y. So we really just found this distance. It's 2.6 meters, but we need to find this. So and this is 1.8. So the total height is 4.4 meters. Okay. So let's try equation 4. Its displacement is 4.4, 9.8. Solving for t. Its velocity is 4.8. Okay, so now we're getting an unreasonable result. Let's get a second opinion. As you can see, it's like it's because she starts here, she makes this path. It makes it more difficult, I think. Okay, so he plugged into equation 5. Okay, so we agreed with this. V naught is 0 because instantaneous velocity is 0. That means it's not moving. That means you're at the highest point, or you're at the local maximum. That's the calculus term. That's what they want you to know. So V naught is 4. So we get V naught over 8. And I'm not sure how they're getting division here. Definitely does not seem, does not seem to be right. These are definitely wrong, aren't they? I guess, like, where is the H? Where is the H here? H just disappeared. So this, I'm gonna say this is a fail. So I'm gonna stick with my 2.6 meters. Okay. Equation 5. Final velocity I don't want to do that. Full time in the air. So let's try F4. Displacement is 2.6. So it should be 2.6 plus displacement. So displacement should be this distance. I think it's saying this is 2.6. So in that case, it makes it a little better. So 2.6, 9.8 time 0.4. Velocity is 4. Position 1.8. Okay, let's try it again. 4.6, negative 9.8. Solving for time. Initial velocity is 4. Initial position 1.8. So we're still getting 0.4 seconds. The language model is hallucinating really bad. Okay, so her feet are in the air, 0.4 seconds. That just seems too short of a time. Two 0.6 is that distance. Let me try something. All right, so maybe we can do some Pythagoras theorem. This is 2.6. We find this. We can probably find that. It's not a right angle though. I guess I can force a right angle. You know, now it's a right angle. So we want to find displacement for that. All right, so let's try equating 5. Final velocity is 0, negative 9.8. Displacement is what we're trying to find. Initial position 1.8. Okay. So maybe really this is 2.6. Okay. Okay, so now let's try enter. Let's try equation 5. Final velocity. Maybe we can solve for final velocity now. From the top down. A 9.8 displacement. So should be 2. Okay, so 1.8, 2.6. So I want to plug in a number here. Mm, so we want the displacement from here, I think. Solving for final velocity. Let's try square root 4.4. Initial position 0. Initial velocity. All right. Think that's all the attempts I can make at this one. And you also have to know, like, the book can just make mistakes too, so for what it's worth. Can I get the height of a cliff? Takes, so T 2.35, G negative 9.8. Okay. So we want to find Y. We want to find this, and then Okay. So I think we're gonna double something in a minute, but all right, fine. The function. What function we want to use? We know t, so probably x, probably 4. Okay, so displacement 0, time 2.358. Why not? So I'm getting y naught is 8.26, 8 meters. Okay. So we want to find how long it's in the air. I want it to reach the ground. Okay. It's throwing down at the same speed. So now we're going to plug this in as this. With y not 0. Okay, so we're going to do. Okay, so we want to know how long it is. So what's t when g 9.8 v naught is 8. Okay. We're going to use equation 4. So 8.26 negative 9.8 time is t. Velocity is 8. Initial position is I think that's wrong. Or displacement. Maybe it would be negative 8.6. Okay. 2.35 seconds. Which is the same here. I don't know if that's what it's asking. So here you're going with gravity. Down you're going with gravity, so this should be a positive. Okay, so let's try those numbers. So I'm gonna do displacement is negative 8.26, 9.8 times t 8 0. We're getting a complex number. It's kind of annoying. All right. think we made good progress today. Pick up on 73 next time. 73, 73. We got going to 115. So probably 3-4 more videos on this chapter. So thank you guys. I'll see you next time.